My name is Professor Rad, and this is Precalc video 118, the discriminant. So in this video, we're going to be talking about the discriminant. So the discriminant is something that helps us determine how many real roots a quadratic function is going to have. Now, when I say a real root, I'm also referring to something called a real zero, which is the same thing as the solution to the equation f of x equals 0, or the x-intercepts of the function. So these are all the same thing, the same concept. So you'll recall the quadratic formula says that if you have ax squared plus bx plus c equals 0, then x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. However you choose to remember the quadratic formula is up to you. There's a little song you can sing, or some folks have made up little stories, whatever's going to help you to remember this. So the x here, because we're equaling 0 in this equation, the x is referring to what's going to be the x-intercept, right? If y is equal to 0, that's an x-intercept of the function. So if I look at this formula, I notice that there is a radical here, and there's something underneath that radical, b squared minus 4ac. Now, suppose that this b squared minus 4ac was 0. Let's just pretend that was 0. What would that do to our quadratic formula? So if this was equal to 0, then we would have x is negative b plus or minus the square root of 0 all over 2a. But the square root of 0 is 0. And whether I add 0 or subtract 0 is going to have no change. So that will be the same as negative b over 2a. What this means is we're going to have a parabola that has only one x-intercept. So this plus minus ordinarily is going to give us two x-intercepts, but because we were plus minusing 0, the plus minus part went away, and we just got one number. So what that means, if I try and picture a parabola that only has one x-intercept, that means, like let's say that's our x-intercept, that means the parabola either has to be smiling there, or it has to be frowning there. So we get this situation where the vertex is the same as the x-intercept. So one thing that can happen for the x-intercepts of a quadratic is you could get one x-intercept, and that will happen when this number that's under the radical, the b squared minus 4ac, that'll happen when that's 0. So I'm just going to write that kind of as a note on the side over here. So if b squared minus 4ac is 0, then we have one x-intercept. And remember, the x-intercept is just another way of saying a root or a 0 of a function. Those are all, we're going to treat all of those words like they're synonyms in this class. Okay, cool. So that was a fun experiment. What if it's not 0 though? So what if this b squared minus 4ac is greater than 0? Let's see what happens then. So if b squared minus 4ac is greater than 0, we're going to get negative b plus or minus the square root of that b squared minus 4ac. Now, being greater than 0 means you're a positive number. So I'm just going to write a positive number here because we don't know what else that is, all over 2a. All right, so now if we're in this situation, we have the square root of a positive number, which is a real number. And then we will be taking negative b plus or minus that real number all over 2a. So that means all components of this formula are going to be real numbers. That means that we're going to get a real number out of it. So remember, this fancy looking e thing just means is an element of. So that means this expression is a real number. So if this b squared minus 4ac is positive, that means that the x-intercepts happen at real numbers. So you could get something like this going on, where we have two different x-intercepts. And we know we have two because we're adding or subtracting the square root of a positive number. So we're adding or subtracting some value. So we could have something like this, or we could have something like that going on. So to add to my list over here, if b squared minus 4ac is 0, then we have two real x-intercepts, or we have two real roots, or two real zeros. So we've talked about when this expression is equal to 0 or when it's greater than 0. How about when it's less than 0? Well, let's see what we would get. So if b squared minus 4ac is less than 0, that means that expression is negative. And so we're going to be taking the square root of a negative number. Now, if you're taking the square root of a negative, you can rewrite it in terms of I. So this would be negative b plus or minus I times the square root of a positive number all over 2a. Remembering that I is the same as the square root of negative 1. So if this expression b squared minus 4ac is negative, that means we're going to end up with a complex solution here. The x-intercepts are going to be complex numbers. Now, if I go to graph on our coordinate plane, this is the real numbers crossed with the real numbers. So there's nowhere for me to put this complex number on the graphing grid that we've been using. So what that means is we have non-real complex roots here. So our parabola is not going to cross the x-axis. So that means we're going to get stuff like smiling parabolas that are above the x-axis or frowny parabolas that are below the x-axis. So to summarize this, if b squared minus 4ac, oh, this should have been greater than. I'm making little typos on the whiteboard. If b squared minus 4ac is less than 0, then we have no real x-intercepts or roots or zeros. And we'll be hovering either below the axis or above the axis. So all of this seems to indicate that if I want to know information about the x-intercepts of a quadratic, if I know the sign of b squared minus 4ac, that will tell me information about the quadratic. So that is what we call the discriminant. So the discriminant is b squared minus 4ac, and it will tell us all of this helpful information. So I'm going to wrap that up formally with the definition of the discriminant, and then we're going to do an example. For this definition, we have the discriminant of ax squared plus bx plus c is that expression b squared minus 4ac. So if you want to pause the video here and write down that definition, you can. You also want to have this information written down so that if the discriminant is 0, then you have one real root, so you have one x-intercept. If the discriminant is positive, then you have two x-intercepts. And if the discriminant is negative, then you have no real roots. So I'm going to step totally out of the way in case you want to pause and copy any of this down. All right, and now let's work through this example. So q of x is 3x squared minus 6x plus 5. we want to find the discriminant and state the number of real roots. So let's do the first part first, find the discriminant. So the discriminant is b squared minus 4ac. So just a reminder, this is our a, this is b, this is c. So we're going to take this -6 and square it, times 3, times 5. So -6 squared is a positive 36. 4 times 5 is 20, times 3 is 60. And then we're going to get what, 24, -24. So the discriminant is -24. I almost left myself enough room for that. So the discriminant is -24. And then to finish this problem, we need to state the number of real roots. So because our discriminant is negative, I'm going to go back to our reference here. If the discriminant is negative, then there are no real roots. So there are 0 real roots. So what this means, since the coefficient of the x squared term, since a is +3, that means this is a smiling parabola. And because there are no real roots, that means it's hovering above the x-axis. So I hope you found this video about the discriminant helpful. That's going to conclude our series of videos on quadratics. In our next set of videos, we're going to be expanding beyond quadratics and seeing what we can find out about polynomials in general. So why limit yourself to just squaring a function? Why not looking at x cubed, or what we can see with quartics or quintics or things beyond that? So I look forward to taking you on the journey through polynomials. And in the meantime, I hope you have a wonderful day. Bye for now.